Hi, you guys. So what we're going to do is go over the G-link protein and find out how and where are they really comes alive. Uh, Basically, certain taste receptors operates via G-link protein. This include the sweet taste, bitter taste, uh, you know, and other tastes too, such as umami. Um, the sense of smell, all right, is via the G-link protein as well. So they're usually indirect, slow, and complex. There could be like a lot of relay molecules that communicate with one another, or one molecule or protein molecule can activate another. So there's some of the uh, receptors are involved in that. So let's go ahead and take a look at a scenario that I like to tell you, and then we'll go over the mechanism, okay? Um, if you put in like maybe a dominoes and put the other dominoes next to it, all right? I like to use this example because what happens is when one domino falls, next one falls, next one falls, next one falls, and so on. So you could see one is stimulating or knocking down one of them is going to cause pretty much all to get knocked down. All right. So a lot of these dominoes in the middle, right, are linked to this one, right? So this is your primary signal, for example. And then at the end of these dominoes, you could put in like maybe a toy car, for instance, in here that as this domino falls into it might cause this toy car to move forward. Or you can put the marble, for instance, here. As this one falls on top of the marble can go and is straight and so on. So basically what happened, these are analogous to the cellular response. In other words, those relay molecules, what do? They cause a cellular response. Cellular response varies, and and depending on the cell, they might do different things. Okay, so what we would like to do is now go over a little bit the mechanism. But while I'm going over that, just think about one molecule activating another. It's kind of like these dominoes. One activate the other, and then at the end you have a cellular response that is similar to the aftermath of these dominoes falling, right? In this case, marbles moving forward or other things and so on. Okay, so the neurotransmitter first is the first primary signal. This is usually known as a first messenger. All right, the first message is neurotransmitter or chemicals. It will bind to the receptor, but this receptor is going to be linked to a protein known as G protein. All right, guano diphosphate, guano triphosphate is similar ideas, but basically what happens is, this G-link protein it gets activated, and as a result of that, that could trigger other things to get activated, like adenylate cyclase. All right, adenylate cyclase can get activated. Adenylate cyclase is an enzyme that can break down the ATP to what's known as a cyclic AMP. In other words, you break down two of the bonds, and then the molecule kind of like reshape into adenosine monophosphate because two phosphate already separated. This causes cyclic AMP to do a particular cellular response, and that, therefore, this cyclic AMP is known as a second messenger. A second messenger. All right. So if you go ahead and take a look at this, is the neurotransmitter is binding to the receptor here. Uh, is my receptor that is linked to the G protein. Now, as a result of one hitting the other, G-link protein gets activated, and this activation causes the adenylate cyclase to get activated. Adenylate cyclase hydrolyzes ATP to cyclic AMP, two of the phosphate bonds break, and now this is called the second messenger. This is as far as what we got. All right, all these molecules, one triggering another, G protein triggering another. It's kind of like a dominoes falling. All right, it's kind of like that. All right. Now this cyclic AMP causing the cellular response. Cellular response means what it could do for the cell. It could do a variety of things. For example, it could open up these protein channel. If these protein channels are for sodium now, as they open up, maybe sodium will rush in. As a result of that, you depolarize the membrane, all right? Or it could be a closure of these channel and inhibiting something to go out, like potassium, for example. It could activate an enzyme. It could activate a gene. It could activate the protein synthesis. So just like the dominoes can do different things earlier, I showed you, all right, they can do different things as well. All right. So depending on the style, they might have a different response. All right. So again, the sense of olfactory, the sense of taste, all right, those are the major, not all the taste, by the way, all right, bitter, umami, and bitter taste, and sweet taste, those are linked by the G-link mechanism. The salty taste, as well as sour, they have a different mechanism, so it's a little bit different. Anyways, that is the idea of the G-link protein, you guys. Okay?